Hello, everyone, and welcome to the next event in our webinar series, a presentation by Thorlabs Photonic Solutions Engineer, Eric Kurywczak. My name is Lucas Lamb, and I'll be moderating today's talk. As a Photonic Solutions Engineer with Thorlabs, Eric offers dedicated custom solution support for both academic and industry customers. Previously working in technical support, Eric had a focus on the Thorlabs Quantum Optics Educational Kit, which allowed him to present it at Clio and Photonics West, as well as invited talks at universities such as UNCC and Rutgers. He also helped to develop the quantum optics experience for the Thorlabs mobile lab that is currently touring the United States, providing students with a hands-on experience. Throughout Eric's talk, please feel free to submit any questions you have using the Q&A tool. He will be answering any questions at the end. Now, I'd like to hand the talk off to Eric.
All right, thanks Lucas, and thanks everyone for joining today's webinar about Thorlabs' quantum solutions. To get things started, I kind of just want to go over how I formulated this webinar. So I'll start with the kind of bare bones introduction to quantum, a little bit more broad, and then I'll go through the process that at least I went through thinking about things when it came to quantum. So starting with getting into education and training on quantum, building up a new lab from scratch, so those lab basics, so starting components, and then also going on to maybe a more advanced level with pre-built solutions before finishing things up with talking about our custom and OEM offerings. So to get things started, let's go ahead and get into that introduction portion. And so you're getting started in, or already working in quantum. This is kind of a difficult subject to get into off the bat, but as you can see possibly in that picture there, there's a lot of components from Thorlabs already being used in quantum industry. So that's from a quantum computing setup that Honeywell has. And you can see Polaris optics mounts, you can see fiber ports, you can see optical fiber. Essentially, the point I'm trying to get across is that Thorlabs is already involved in this industry and supporting it. What we're trying to do with this webinar is help you figure out where we already are standing, as well as what we might be able to do to help you in the future. So with that being said, what problems are there currently in the industry? Well, it's a complicated and fairly new field. By complicated, I mean anytime you talk to a physics major, for instance, which I was, and you tell them that you're going to be taking a quantum course, the fear of the math that you're going to have to deal with to handle the theory is definitely there. After being in the industry for a little while now, I've got to admit it's a lot more fun doing the experimental side and being able to play around with the components rather than doing all of that math. But to each their own, I'm sure plenty of people do enjoy doing that math side. Another big point would be the miniaturization aspect. So kind of thinking back on that Honeywell quantum computing setup, you're trying to fit a lot into a very small footprint. And as with any burgeoning technology, if you just want to think back to the original computers, take up a lot of space, aren't super user-friendly. In a lot of cases, there's a lot of shrinking that needs to be done so they can be commercialized and brought into a broader market. And then the last one, which I guess there are plenty of them fit into there, would be those stringent specifications. So you've got a lot of loss tolerance concerns, you've got requirements on your wavelength and the line width of that wavelength, you're concerned over detector efficiency, so on and so forth. So there's plenty that we need to be solving over the next few years and certainly into the distant future when it comes to helping support the quantum industry. And like I mentioned before, the way that at least I got started into quantum was with our educational kits. So as far as covering quantum optics in particular, we've got 3 different offerings. Right now, I've got shown on screen our quantum eraser demonstration kit and the quantum cryptography analogy demonstration kit. And I must admit, saying cryptography is always going to be challenging for me, so just bear with me if I have to say it again and I mispronounce it. At any rate, both of these are considered classical analogies. So they're both using visible light classical sources, essentially just laser pointers, and they're really geared towards the entry, easier, lower budget, getting across the core principles that you're working with in quantum, rather than having you create a non-classical source, for instance, which is what you will end up doing with the quantum optics educational kit that I have a fair amount of experience with, thanks to demoing it at Clio, like Lucis mentioned, having it at Photonics West, also introducing it onto our mobile lab. And last week, actually, just hosted a alpha immersion where we had a few professors stop by, test out the kit over the course of 3 days, and see if it'll be a good fit for their lab teaching environment. With this kit, you're actually going to make your non-classical source. You have a 4 or 5 pump laser, a type 1 BBO crystal, and you'll end up having a spontaneous parametric down conversion to create your photon pairs that are going to have time energy correlation. You've got 3 single photon detectors included, as well as a time tagger that we get in partnership with Schwabian Instruments as a special. So really a fantastic kit to get things started, to train up new people in the industry, or to just get yourself educated in a university environment. I do want to make sure I mention that there is a polarization entanglement add-on that's in the works. If I'm not mistaken, it should be getting released sometime at the end of this year or the beginning of next year, but don't quote me on that. Now, from the educational side of things, I also want to mention that we do have a lot of incredibly detailed manuals that are put together by the team. I believe those are linked down below, but you can also access them easily enough from our website for free. You can download them, make use of them without having the kit, really whatever you feel is appropriate there. Now, for kind of the next level up from getting educated in quantum would be building up your own lab, your own experiment. For that, I think at least the most natural starting point, because I at least don't like working on the floor, would be to get yourself a table, a breadboard, science desk, some sort of above the ground working equipment. So I'm showing right now a few different options. We've got our optical tables on the bottom there. Those are going to be your more heavy duty solution, but also for kind of the breadboards and science desk side, we've got those on the top left corner there. The science desks in particular are incredibly customizable. You can get a laptop stand for it. You can get a keyboard holder. You can get all sorts of different shelving. And we also have a adjustable height version that we demonstrated at SFN, Neuroscience, for those of you who aren't familiar. And it actually makes it so you can raise the height of the table up and down, which, at least for me being 6 foot, is certainly helpful when I don't want to be hunched over and ruining my lower back any more than it already has been. Now, from on top of those table surfaces, we could make use of an enclosure. So I've got a couple shown on the screen right now. These are some stock offerings we have. We have some that are even simpler than that, where it's literally just a drop down on top of whatever your setup is and have it enclosed. But there's different door options. We got those sliding doors, we've got hinge doors, and beyond the stock options, we certainly are capable of helping you with custom sized enclosures if needed. So feel free to reach out to us about that. As far as keeping things light tight, we also have those laser safety and blackout curtains. So that setup on the bottom is showing one way of doing this, where you actually have a frame that goes around the optical tables. You could also get the mounting hardware, so you could set it up depending on your room layout if you don't get a table that has that kind of frame style. One last thing when it comes to these tables and breadboards would be mentioning that you can get either rigid, passive, or active supports. For the quantum industry, given the accuracy requirements that you have and stability, I'd say you'd go with either the active or passive. Of course, that decision is going to be something that you'll have to make on your own, and we are more than happy to be involved in that conversation with you. As far as other stuff you'll be putting on top of your breadboard or table, we've got all sorts of different mounting hardware. Lucas, my moderator, just recently had a webinar about our Polaris line of mounting optical mounts. Apologies. So these are incredibly high-spec mounts from us, where they're already being used in a lot of our laser systems, for instance. I know other companies are making use of them in their systems as well, and they offer unparalleled stability. They're going to have that vacuum compatibility component, and they also are just generally long-lasting. You can use them over and over again without worrying about them being worn down pieces of equipment. Coming up from there, we've also got our Elliptech line of motion control. So I know that the rotation mounts in particular are quite popular with the quantum industry because of polarization control elements, where you can just introduce your linear polarizer, half wave plate, quarter wave plate, whatever have you. And it comes in that nice OEM packaging, which makes it easy to integrate. With these, I want to make sure I mention and highlight that we will be releasing a half-inch version of them in the near future. Once again, I'm going to give you a date that may or may not change, but I'm going to say it anyway, and they should be coming out, if I'm not mistaken, in November. So keep your eyes open for that. It'll help you shrink down those footprints that little bit more, and it will still be cage compatible if I'm not mistaken. So just wanted to make sure I drew attention to that. The last one that I really wanted to focus on for quantum on this side of things would be the optical fiber. So we do a lot of different stock offerings already on the website, whether it be single mode fiber, multi-mode fiber, polarization maintaining fiber. But you may not be aware that we also have a custom tool on the website where you can actually input what fiber type you want to use, what tubing, what termination, so on and so forth. So you can actually design your fiber right there on the website. It'll give you pricing and lead time, dependent on how many you're looking to get and how long, of course, because there's some constraints there as far as how quickly we can get it out to you, but really makes things easy to get started. So with those things in mind, the next step, at least in my mind, would be getting your source together. So I've got our BBO crystals up here. These are a fantastic addition to our catalog, both the type 1 and the type 2 options. I've got a couple mixed up on there for you to take a look at. One thing I particularly love about these is that they have the markings already on those housings. So you don't have to play 20 questions if you put your hand in a drawer, pull out an optic, and it's not marked in any sort of way. People didn't keep it in their box, whatever have you. So all the information you might need is there. You know what type it is, you know what wavelengths you're going to be working with. You've got that polarization information and that rotation axis. So with that, you of course need some sort of pump laser, generally speaking anyway. So we've got plenty of different packaging and wavelength types available. So we've got the TO-CAN laser diode style on the right there. We've got the pigtail TO-CANs on the top. We also have butterfly packages. And then for our ultra low noise laser users, we've got the extended butterfly as well. So again, plenty of choice when it comes to that. And we are always willing to hear out what you need and see what we can do to help further. For these laser diodes, of course, you need some sort of mount and driver. So we got plenty of different options there as well. We've got simple solutions for the TO-CANs. We've got options for the butterfly and extended butterfly. And we've also got options for our pigtail TO-CANs. So for that CLD 1010LP I just pointed out, I also want to mention there's a CLD 1015. That is going to be for the butterfly diodes. So both of those different styles, or drivers rather, are going to be all-in-one solutions. So you'll put in your pigtail TO-CAN, your butterfly, and you can control the current, you can control the TEC. Really, it's just ready to go off the bat. If you're going with, for instance, that LDM90 or the LM14TS, then you would want to get a benchtop controller for the current or TEC, or both. In this case, I'm showing one of our dual controllers, the ITC 4005. Simple enough, plug it into your mount, plug it into an outlet, and you're ready to control that the current as well as that TEC. Now, from here, I kind of want to just draw attention to a couple of interesting products, at least in my mind, being our tunable narrow bandpass Fabry-Perot filters and our NV-Center diamonds. So the Fabry-Perot filters in particular, I think they're incredibly cool products. I think that they're way more versatile than just being for the quantum market. But being that you already are working with those low loss tolerances, these are a fantastic addition because they allow you to keep your pump out of your signal. And when you're working with a really low signal to begin with, that's incredibly helpful. We're very conservative with how we spec these. If I'm not mistaken, we spec it at 80% transmission, but I've been told many times by the department that handles them that we can certainly do better than that. So if you have a particular wavelength that you're looking to work with and you need a certain amount of transmission, we want to hear from you. We want to see what we can do to help you out there. When it comes to those NV-Center diamonds that I have on the right, I'll admit I don't know a ton about these beyond some of those use cases. So the magnetic field sensing, RF detection. Really, these are kind of an interesting product to me, but I don't know a lot about them. And I'm hoping that those of you watching will be able to give some input on your uses. In particular, we kind of want to learn how you're mounting them. I've heard at trade shows about people just using double-sided tape, for instance, or in some cases, I think I recall somebody mentioning using hot glue. Weird ways to mount it in my mind, but if it works, it works. And the other thing I'm mentioning on here is that we do offer these in partnership with Element 6. So that partnership allows you to just buy one or two, a handful of them instead of having to buy in bulk, for instance. So that's kind of that little bit of added value that we're throwing in with that addition to our catalog. Now, here I've kind of come to the end of that starting from scratch theme that I've been going with, where you're getting, basic components and putting them into a system. Next up is going to be some of our systems that we have already. So the low noise narrow line with laser systems, for instance, the ULN15TK and the DFB15TK. These are fairly new additions as well, and they're both turnkey. So by that I mean, of course, you can just put it down on your optical table or breadboard, plug it in, turn it on, and you've got your source ready to go. The ULN15TK has a 100 hertz line width, and if you pair it with the optical reference cavities that I have on the right side there, you can actually get into the sub-hertz line width range. We have a diagram on the website, which I considered throwing into this PowerPoint, but figured it would make it a little too busy. You can always reference that information to kind of do that design system on your own end as well, and we're more than happy to help out, of course. The DFB, you're going to be looking at a 50 kilohertz line width, but you're looking at a lower price point, and another benefit of that system is that you're going to have mode hop free tuning. So in certain applications, that is going to be valuable. Kind of going back to the reference cavities, I want to make sure I mention in particular that we make the supercrystalline mirrors that get used in these. So we can do customs of them between 1 and 5 microns currently. If you're working outside that wavelength range, we certainly want to hear from you to figure out what direction we need to be moving in as far as developing out that capability. So if you're looking for something along those lines, please make sure you put a comment in and tell us what wavelength range you're working with, and maybe there's a good chance that we're working in that already. Next up, of course, I can't forget to mention our single photon sources, or pair sources more accurately. And for this, we've got these two in particular, the SPDC810 and the SPDC810N. Both of these are quite similar in the sense that, of course, they're outputting 810 nanometer photons. But with the 810, you're going to have a higher power pump laser. So you're going to be getting over 450 kilohertz pair rate generation rate, according to our specs, versus the 810N, where you've got instead more of a focus on the increased indistinguishability. So you're going to be getting instead with that one around 100 kilohertz out of the pair generation rate. Two great additions to our catalog. I mean, we've had the pair sources for a while now, but the SPDC810N is definitely geared towards more of that high accuracy application style. And both of these, I will mention, are software controllable, but with the 810N, you also do have the ability to control it with that front panel. So in certain cases, that may be helpful. I'll leave that up to you, of course. With that, the next thing up, because I like a bit of symmetry in talking about products I know the most about, would be our single photon detector modules. So the SPDMA in particular, I have plenty of experience with because it's what's used in the quantum optics EDU kit. The SPDMH series, which is shown on the bottom left there, I have less experience with, but I am still familiar enough with how these things operate to be able to talk about them. And really with the SPDMH series, one thing I do like is that we have a fiber coupled version already available, actually technically 2 of them. And these, you can just pair it right up with your SPDC810 or 810N, and you're ready to go with your heralding setup off the bat. The SPDMA, I like in particular because it's got a nice safety system built in that's great for, I guess, newer people to the industry where they might not be as careful with not shining too bright of a source onto it and potentially causing damage. So in that sense, I mean that for the kit, it's designed so you can actually use the alignment laser on it without causing any damage. Even if the detector itself is on, it'll just kind of shut off that signal and keep itself from getting damaged. A newer addition that I'll make sure I mention is the high quantum efficiency balanced photodetectors. So these are great little OEM products. You can actually see just how small the actual chip of it is compared to the termination on it. So easy to integrate, good for the quantum interferometers and that kind of quantum sensing field. Neat little product. And just kind of to wrap this out, I do want to point out that I have taken some data using our SPDC810. So I got myself in the privileged position of working here at Thorlabs where I have access to some of our equipment. So I just took one of the SPDC810s that I was allowed to borrow, put it onto the same breadboard as our quantum optics kit, did some fun playing around with some other components to make it work, and then had myself the experiment for the Michelson interferometer with the quantum kit running with that SPDC810, and got, I think, some pretty good data, considering I didn't spend a ton of time getting things squared away on it. Even those G2 values are certainly within the realm of saying, yes, you've got your quantum source. And with that, I've got our catalog stuff at least covered. So at the end, I'll be able to go over some questions on these. I just, wanted to make that a point. Now, when it comes to custom capabilities, I'm on the solutions team at Thorlabs here. So customs are what I'm handling on a daily basis. We've got custom fiber, as I've mentioned several times. On the top left corner, you can actually see a couple of our fiber draw towers where we are able to make that custom fiber, or some of our stock fiber as well, of course. We've got significant amount of machining space. If I'm not mistaken, globally, we have over 1 million square feet. So that's really a great resource to be able to take advantage of with us. And then also on this slide, I've got pictured our custom optics, as well as a good picture of the manufacturing of our optical tables and breadboards. So when it comes to custom optics in particular, of course, Thorlabs is known for making a lot of optics. We actually expanded that capability with the acquisition of our Thorlabs lens systems, which used to be JML Optics up in Rochester, New York. They allow you to take advantage of the quick turn optics capabilities to get a system prototyped and developed in generally very quick times compared to a lot of other custom manufacturing. As far as other customs that I want to make sure I mention, we are able to do, of course, custom motion control, custom detectors and sensors. Really, if you have something that you need that's in quantum and we don't already have it in our catalog, we want to know what you're looking for. We aren't really in that mind reading position as a species yet where we can know exactly what everybody needs. So I really want to make an emphasis on that point. And kind of sticking on that point, I want to draw everybody's attention to the link on the screen for our Hungry for Your Thoughts page. Here you can actually just input whatever you think we might need to work on. If you're working on a particular project, give some application details. Tell us what sort of item might help you get further along with your project. Let us know if there's an issue with something that we already have that you might see an easy way for us to make a change and fix it, improve it, so on and so forth. I'm sure those of you who are familiar with our website have seen the customer-inspired products. That's pretty much entirely where these come from. So it's a lot of visibility that you get directly with our team and with our manufacturing divisions to be able to take advantage of that tool. So with that being said, I want to say thank you all, and I appreciate you attending this webinar.
Great. Thank you, Eric. Thank you for that informative presentation. That was really great. We already have a few questions. And again, I'd like to invite everyone on this webinar to submit your questions at this time. So we'll start with one here with some feedback and a question as well. So the EDU QOP1 looks great, especially with the custom extensions and the future add-ons. But some of its components, like the K-cubes, for example, are now classified as obsolete due to the release of new components. So the question is, will there be an updated base EDU-QOP2 or similar in the near future? Should they hold up for it or jump on the initial version?
They are working on updating the bill of materials, and if I'm not mistaken, of course, also the manual. So that change, I can't say I know when that's going to be coming, but they are working on making that as soon as possible so that it can be updated. As far as whether you should wait or not, I can't really speak to that. I mean, I'm a fan of as many people having their hands on this kit as possible. That's why I was such a big proponent of getting it our mobile lab. It will simplify the setup a little bit because instead of having 2 K-cubes for the piezo stage, you just have 1. So if that appeals to you, I'm not going to say, you shouldn't hold off, but really it's kind of a judgment call on that side of things.
Yeah, great. Yeah, I'd say if there's any question follow-up after that, you can definitely reach out and we can discuss the benefits and whatnot. Following that one up, could you give a quick explanation of SPDC for the uninitiated?
Gotcha. I mean, for spontaneous parametric down conversion, so you've got your pump laser at a particular wavelength. For the quantum kit, it's going to be that 4 or 5 nanometers. It's going to interact with your BBO crystal, in this case, type 1. So it's going to have the kind of absorption of that light, and then it's going to generate your photon pair from there at instead 8, 10 nanometers. And that is going to have a time energy correlation, let's call it. I've been told to skew away from entanglement whenever possible, generally. Maybe I was given incorrect advice on that, but I'm going to roll with it just in case. So hopefully that was a sufficient explanation for all of you.
Yeah, thank you. And just a quick reminder again to the audience, if you have any questions, you can still write them in. There's still time here. Maybe branching off that SPDC question, do you have any guidance on which SPDC models is appropriate for a certain application or user? I think you had the comparison earlier. Yep.
Yeah, so as far as application specifics, I will be the first to admit I haven't worked a ton with either of these to be able to give very specific information on that. I would defer to kind of the team that handles these in particular. But I will say, if you're looking for just that bright source to get your photon pairs no matter what, and know that they're coming out, you might be good with the SPDC 810. But if you're looking for the really high accuracy side of things, then the 810N may be a better way to go for you. There's definitely more of a conversation that I think we should be having with you before you go and choose one or the other necessarily, because we do have an incredibly knowledgeable team focused around all of our quantum technologies, and these in particular are something that we've been working on making sure that we're giving dedicated support to when it's called for.
Great. Yeah, thank you. A couple more questions I think we have the time for. Do you have any setup to demonstrate quantum entanglement? Branching off your last note about using entanglement.
Not that I can think of off the top of my head. Technically, the add-on that's coming for the quantum optics educational kit will be showing that polarization entanglement. So you will actually have a setup instead that's slightly different from this. I don't know the exact difference in the number of components that are going to be added, but you will have a couple compensation crystals for some spatial and temporal walk-off. But otherwise, it's just kind of the change on the crystal side so that you do have that entanglement factor. And you'll be able to, if I'm not mistaken, they're working on making sure you can test Bell's inequality. And there's a couple other experiments that they're adding, but it's a little fuzzy off the top of the head. Certainly something we're happy to get into a further conversation with. Sorry if that wasn't clear, though.
Yeah, thank you. And it's so it's 12:30 Eastern at the moment. I think we'll do one last question for now, and that is, do you know of any of these quantum educational kits in Southern California or elsewhere? A visitor would like to potentially visit and check it out. Do we have any on-site, in-person options?
I don't know the list of who in particular has purchased the kit. I could certainly look into that, and I'm hoping that our educational team is aware of the people that do have the kit, considering it is a involved kit to be taking advantage of with a lot of support. I know that there are universities in California that have purchased it. I just don't know which ones and where necessarily in California. Our mobile lab also, it does travel around the country. Will, I'm sure, be out in California again soon enough. So if it's something that you want in particular, I would recommend bringing it up with your department, seeing if they can encourage our mobile lab to come there for the quantum optics experience. So potentially you'll be able to meet me in person while I'm running it, or one of our other people on that team will help you out.
Great. Yeah, thanks again, Eric. I believe that is all the time we have for today. If there are any other questions, you're welcome to email us directly. I'd like to thank you, Eric, again for your presentation. Join us again next week for a guest speaker, Galen Moody from UCSB. Professor Moody will introduce the field of integrated quantum photonics and its recent advances. You can register for this webinar by clicking the Register Now button below or on our website at www.thorlabs.com/webinars. Thank you very much for your attendance, and we hope to see you again.
Thanks, everybody.